Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. I'm James Titko. This week's question comes in from an anonymous listener. They say, how do you calculate the magnification amount of a small clear marble? My son has small clear marbles, 5/8 of an inch diameter, and he's just figured out that when he holds it right up against something, it majorly magnifies whatever it's up against, be it pixels on the TV screen or the woven fabric of a trampoline or carpet fibres. I'm assuming other scientists have known of this for centuries, but I'm struggling to find a formula to figure out exactly what magnification our particular size of marble is producing. What a fun question, and to answer it, we're going to need to consult the science of optics. To help me, I'm joined this week by Richard Bowman from the University of Glasgow.
Thanks, James. A clear marble will act as a lens. Because the glass slows down the light that travels through it, it will bend light whenever it passes through the surface at an angle. That's known as refraction.
To calculate the optical magnification effect of the marble, we need to find out the focal length of the lens. This is the distance at which the light passing through the marble converges to a single point.
For that, we need to consider the radius of curvature of the marble and its refractive index, which measures how much light gets slowed down by the glass. A typical marble, made of normal glass, will slow light down by about a factor of 1.5, and it might have a diameter of perhaps 12 millimeters.
If you carefully trace the rays of light as they get bent on the way into and out of the marble, you come up with a focal length that's a function of both the refractive index and the size. And for the numbers Richard mentioned, that gives you an effective focal length of 9 millimeters. That means that you could hold the marble next to your eye and be able to focus on an object only 9 millimeters away.
The magnification this gives you is a surprisingly tricky concept. Technically, the ratio of your marble's focal length to the focal length of your eye sets how much bigger the image on your retina is than the object. However, that's not how we normally define magnification, because you're used to looking at objects quite a long way away, and most microscopes define magnification relative to looking at an object about 25 centimeters from your eye. So if you're reading a book, we would be kind of defining that as a magnification of 1.
So that means the magnification will be the ratio of the focal length, 9 millimeters, to this distance, 250 millimeters, which suggests you have a magnification of about 28 times, enough that you could easily see the pixels in a typical screen. If you use a smaller marble, it scales linearly, so a 6 millimeter marble would give you twice the magnification.
You're right that scientists have known this for centuries. Indeed, the first microscopes were just small glass balls. And by using really small ones, only a few millimeters, early scientists were already able to see microscopic features like cells. Indeed, the name cell came from the appearance of plant cells, which the observer thought resembled the cells in a monastery.
What a wonderful piece of trivia to end on. Many thanks to the second to none Richard Bowman from the University of Glasgow. Tune in next time when we'll be answering this question from listener Christopher. What law of physics dictates that nothing can travel faster than the speed of light? If you have any thoughts on what we discussed today here on Question of the Week, please tweet us on @NakedScientists or log on to the forum on the website to join the conversation. If you've got any questions yourself that you'd like us to tackle, send them by email to chris@nakedscientists.com.